everyone, and welcome back from the short break. Next speaker is Gina Dion. Gina serves as a data scientist in the Office of Institutional Analytics at Indiana University. So join Gina to explore our Shiny applications in higher education. Gina, the floor is yours.
Thank you very much. First of all, can you all see my screen with slides right now or no? So thank you for attending the session today, where we're going to talk about case studies of our Shiny applications in higher education. My name is Gina Dion. I'm a data scientist, data analyst at Indiana University, and I would like to also recognize my colleague Stefano Farini, who's been an incredible leader and supporter in this space as well. And really what has driven our support, our use of Shiny at Indiana University is to try to create an environment of decision-making that's analytics informed. And at Indiana University, we are most definitely a Tableau institution. We use it basically for all of our internal and external reporting, for digital data visualization, as well as business intelligence needs. So what Tableau is great at is providing, a mechanism for allowing users to visualize data, to filter and interact with data, but it has a lot of limitations in the analytics and statistical space. So what we've been doing is really using Shiny to take advantage of being able to embed analytics in sort of the products, data products that our office puts out, and really create ways that non-technical users can get an introduction to analytics and really leverage analytics to gain insights from the data. So what we have done recently is for the Association for Institutional Research, which is a national consortium for institutional analytics in higher education, institutional research in higher education, we have published a series on applying and producing Shiny applications for institutional research. So that's the link there, and we encourage you to take a look. Really, the use of Shiny is what we discovered is pretty new in higher education, but we're very excited about its use at IU in particular, and we're going to show two examples today in ways that we've used Shiny. The first being developing a distance-based matching program assessment tool. So let's first start with defining what we mean by program assessment in the higher education space. And what this means is usually two different things. We might want to, evaluate or assess the impact of a program that's provided for students. So, maybe a student is participating in a specific residential space on campus, a living learning community. Maybe they're participating in a specific research program. Does the participation in that program really lead to, or is it associated with higher outcomes of success? Are they more likely to have higher GPAs? Are they be more likely to be retained, etc.? Or we might want to assess an impact of a particular intervention or a policy on campus. So, maybe it's these new admissions test policies making the SAT or ACT admissions tests optional. Do we want to see what that impact is? Or is it, a student, we provided tutoring service for a student? Is it really making an impact? Of all the things we could be doing with the limited time we have, is this really making a difference for students? So that's what we really mean for program assessment in our case. So how do we go about conducting program assessment analyses? So fundamentally what we're trying to do is compare the outcomes of students who participate in one of these programs or interventions to those that do not. So what we might do is compare them against the campus average, or we might compare the outcomes between the two groups, those who participated and those who didn't. But really the problem is you can't make apples to apples comparisons, right? There may be reasons why students are different who participate in a program. For example, math tutoring, if we think of that, like the reason a student might go to math tutoring is because they have lower levels of math preparation. So if you just automatically compare those against everyone in the math class, you're going to really potentially mask the impact of the program. So what we try to do here is we've implemented matching methodologies, which essentially try to create an experimental data set. So you take students who participated in a program, but we find their most similar pair, counterpoint peer that didn't participate in the program, so we can compare more apples to apples in that case. So we're trying to essentially create a data set where our treatment, those that participated in the program, those who didn't, are really similar on average. So what we did for this is we developed in our Shiny application to help with the frequency of requests. So what it does is it accepts a CSV file of data that we prepare for the analysis. And you can get to it through this GitHub site. We'll also provide a link at the end of the presentation, but it allows you to upload that file, specify how you want to match students through, and then it computes a distance score, which will allow you to match similar students. And then it allows you to download a data set to be able to feed into an analysis. So, and with this really behind the scenes, we're really leveraging ours Match It package, which is phenomenal for doing propensity score matching and other distance-based matching. So what I'm going to do now is show you the application. So this is what it looks like when it's launched in the browser. You navigate to a particular CSV file. So I'm going to navigate to a CSV file that I have loaded. It's a simulated data set. And what it does is when it loads the CSV file, it populates all the columns that were in the file into these various drop-down menus. So you can then select what field identifies a unique user. So it's my ID column in this case. What identifies those who received the treatment, those that didn't. Treatment flag, what characteristics do I want to define to match a student? So I might pick the course they're enrolled in, female, ethnicity, high school GPA, and so on. And I can select the outcome variable I want to compare. In this case, we won't be using that, but you can use these menus to do so. And then you can also use these menus to change different variable types as well. So behind the scenes, female is a 1-0 column. So I want to make sure that that's being read in R as a category, not a number. So I'm going to change that. I hit submit. It populates these menus to review my data types. And then which variable, I can select which level of that treatment variable identifies who received the treatment. So it's going to load all possible values that were in that column. So this was a column of had two values, control, treatment. So I'm going to select treatment. Then for every matching variable that I selected in this, in the previous tab, it's going to populate a slider, which allows me to select the weights for a particular variable. On the slides, I had posted a link to a distance measure that we utilize. So it's using, allowing you to select weights that are most important to defining the distance. So I'm just going to, select those here. Again, this is just for illustration purposes. In the GitHub site, which is linked to at the end of the presentation, you can see a user guide for how to use these weights and so on. And then we can select a matching algorithm that we like. This is going to feed a specific parameter to the match it function in the R code to use a particular matching algorithm. And then I'm going to select the number of controls that I want to match to each treatment, each student. So the number of students that weren't in the participation group that I want to match to those that were in the participation group. I'll select 1. And then what it does is it does the matching and then allows you to compare the balance of the treatment and control group before and after the matching. So you can see before the matching, the treatment is very much being highly more likely to be in the entry bio. And then after matching, you can see things are pretty stabilized. Your control group, the subset you selected, you match to is very similar to the treatment. And the same goes for selecting different variables. So you can kind of go variable to variable saying, I did the matching. After the matching is my treatment and my control group basically pretty similar, right? So then after you do this, you can use these menus to download a match data set and a parameter file that then you can feed into a analysis. So that is one of our tools. The other is we developed one for peer institution development. So our chancellors were really interested in how do we select smart peers? Who do we identify as being most similar to us in terms of enrollment, student profile information, and how might we develop those smart peer groups for benchmarking purposes? So what we did quickly is it's very similar to the other application we created. It has a data set behind the scenes. Campus leadership can select what variables they want to use to find institutions that are most like Indiana University institutions. And then they can select the weights such that they want to define their peers. And then they can get an export essentially of what institutions are most similar. So in the application quickly, this is you select a campus, select a few variables that you want to define peers, you set the weights, and then they go to this and can see the most similar institutions to them. And so say I want to go back and select something different, I can do that and then see how things change. So these two apps have been very good at getting us into the RShiny space, and they've been very helpful for us. And we're looking forward to utilizing Shiny more in our institution, and also sharing with others what we are learning and how we can better utilize Shiny in higher education. So with that, I will stop and then leave it open for questions.
So thank you, Gina. Do you see any application of the modeling you have to e-learning, probably?
I apologize. Could you repeat the question for me?
You see any appliance of your model and design app for e-learning analytics? So for
yes, for e-learning, that's a really good question. So we've seen, so you might want to see, to what extent is a certain level of online learning? Is it taking only, half of your courses online, or is it taking all of your courses online? What impact that has? So that can be used for that as well. We've also done some interventions at Indiana University where students, through their online presence and how their measures in the learning management system of navigation time, being submitting certain assignments. We can find students that are on a low submission rate. We've done that, and then match them to students who aren't perform or who then we do an intervention, right? And then if we compare those that did have the intervention to those that didn't, and then see what the impact is. So that's in the e-learning space, this could be used.
Thank you, Gina. You can continue. In the chat, there is one more question. You can reply. And
okay.
Great presentation.
Thank you, guys.